Hi, my name is Ronan Collins, and this assignment is on reducing Gaussian noise from colored image. For this assignment, I designed my image smoothing algorithm by using the following methods: median filter, 3x3 box averaging, and a hybrid median filter where I used the cross and the corner neighbors. I use a feed-forward implementation where each generation was fed back to the filters to further improve the smoothing effect. After trying a few graphical interfaces, I settled on processing 3.5, which is this, because it takes care of the graphical part and allows me to spend my time designing and developing the algorithm. My program is written in Java. Processing has a few built-in libraries. I only utilize the least necessary. These includes pimage, which facilitates the loading of images to the program, settings in setup, which tells the program how to set up, keypress, allowing the user interactions while eliminating the need to start and stop the program to load additional code as easily as button press, and the drop method, which is a loop that repeats for each frame. These methods are coded in blue. So let me go ahead and go over my code very quickly. So I have several global variables, including pimage, which will be my load. I have several arrays to hold several different keys. As I go through, I will explain what they are, and a few other ones to toggle between which image I want to load or which type I want to apply the settings on. Let me run it. So when it runs, I have this 4-tile display where the first picture is the original. Currently this one is the 10% Gaussian noise. After it goes through the first generation of the filters, it will print out here. When I feed this back into the filters, I get the second generation and then the third generation. I have several different settings. For instance, depending how far my mouse is along the width of this board, will affect the weight. So for instance, if I come all the way to the end, you can see down here that the weight is at 100%. 100% meaning it's essentially almost not being used at all. As you can see, this one is very pixelated. Whereas if I'm all the way on the left-hand side, it's applying the weight being 0, which is applying to all pixels around it, regardless of color, almost. I'm also using the type average. So if I switch to the median, you can see how that affects the image. So I can also toggle between different images. So this is the original 0 Gaussian noise on the image, the 10% Gaussian noise, the 5% Gaussian noise. If I switch to averaging again, this is what the 5% looks like with the weight of 0 and the 0 Gaussian noise image and the 10% Gaussian noise image. For this image, I see around 40 is the weight of 40 is the best, that gives me the best result. So as you can see, using averaging, there is very few pixels. Let me use a magnifying glass to provide a better view. A little bit more. Should be good enough. So at this is around 40, and as I click, I can increase or decrease. So this is around 20. Let me change the median. This is median filtering. I also added additional pictures for comparisons. I found some online. So these pictures, I scaled it down a little bit in order to fit within the original 277 by 277. These turn better around a 40 weight. So right around here, I can see that this one is mostly clean. There are noise which is too large for this method to correct, but generally it's pretty good. So this picture is at 10% Gaussian, 5% Gaussian, which I can reduce the weight to get a better picture. That's probably the best I'm going to get there. This is around 40 as well. Then I have several other pictures. I like this one because the yellow and black blotches, I was not able to clean up some at 10%, but at 5% it looked much better. 10% on this one, 5% on this one, and I believe that's all the pictures that I have. Now let me go back to the code. I should probably keep the magnifying glass. Makes my code a little messy, but that's fine. Okay, so I have setup, creates the title, the location on the screen, loads the default image, and then loads the feed forwarding architecture, passing my image to it. Key press. Depending on which key I press, as I demonstrated, will load the appropriate picture, and TV changes between median and averaging methods. Here is my in. The image array holds each generation. On the final output, I have image 0 on the left and image 3 on the right. RGB array will hold the values for red, green, and blue within this array for each iteration, for each image, in each generation. And here I just go through the process of extracting from the original picture the colors, storing them into the RGB array, and then combining them into the image array to create the picture at full color. I use the three-dimensional to get the neighbors, being depending on which method I was applying. So I have 3 different filters going. These different for loops essentially are just extracting the neighbors from the main image, storing them into the neighbors, storing the colors of each pixel, and then storing those colors into the neighbor array to hold everything that I need. This one passes the full completed neighbor to the activator, including the weight. And I don't remember what this does. Activator. Here I have a loop, and the test toggles between which filter I want to apply at a time. So there's 3 filters within this activator. The first filter applied is the one where it uses the 3x3 boxes. This test eliminates the center box but counts everything else. Second time it's applied, it's using it's either the cross or the X. I believe this is the X, where you get the corner boxes, and the last one would be the cross. Depending on which iteration, it will collect the minimum, maximum, and sum to generate the average. And this one is for getting the mean value if I'm not using the average. I need to put some notation still. For the mean, I need to sort the temp array in order to find which one is the middle. For the average, I just calculate what the average is based on the sum of all the values. And then I return the value of the pixel. So depending on which, I'm using a custom determination to figure out when to replace the center pixel or not. The type is, if the type is either averaging or median, then you'll return either the average or the median. And if a pixel did not pass the check of the weight, then you'll just return the original center value without doing any modifications to it. And draw simply just does a loop where it prints out. It doesn't update every single frame. This program is designed more for animation, but it does this job very good when I'm using mouse clicks to iterate through the generations. And then it just outputs to each strain. These 3 loops essentially pick the generations and applies to the right panel. And that's pretty much it. Let me go ahead and run it one more time. So let's go with the 10% Gaussian. Let's apply almost a 100% weight. You can see how it's blurring using averaging. If I switch to median, you can see how the picture on this generation 3 looks much differently. And to compare it to the original picture, you can see the detail on f16, and let's come back to a more appropriate 40% weight. You can see the original f16 number is a little bit blurred, even though there is no noise. Compared to the 10%, the f16, it's still very readable, including the US Air Force, whereas the original picture here, even the US Air Force is already blurred, but it's still very legible on the 10% at around 40% weight. That concludes my presentation. Thank you.